Good afternoon, everyone. Thank you for showing up and coming. My name is Gabriel Armas, or Gabe, and I'm the asset manager at Pepperdine University. And I've been working with Cyril, and this is basically a presentation on how we are able to consolidate Revit information, data, for facilities and in preparation for GIS. Should I introduce you? Or?
No, go ahead.
Okay.
I'll introduce myself.
Okay.
Thank
Awesome.
you.
So my background is, and let me just keep track. Let me just start my timer. I'm sorry. I gotta stay focused. My background is logistics, material management. I did a lot of work for the government. So I worked in the military, supporting the F-14, Northrop Grumman, and let's see, there's an F-14, and I gleaned a lot of working in the military. I was able to work in the space manufacturing, so we manufactured the GIS equipment that supported the satellites. So I got firsthand knowledge of all the materials, the traceability requirements for manufacturing, requirements in military, civil aviation. So I want to preface with my background because I have a little bit different perspective on traceability. So what I've been doing is just working, trying to understand what we need to do at Pepperdine to obtain all this information. So I worked a lot with circuit boards. So a lot of the components I tracked all the way from when it hit the dock to actually being installed. So if we put conformal code, whatever we put on it, I had to be responsible for it. So that gave me the discipline to look at a drawing or maps. So when I see the circuit board, I essentially see the GIS map, or I see our location and seeing how all of this information connects. So a big concept for me has been understanding what do we call the components? What's the name? What's the syntax? How is the language being set up? Because that language is going to be parameters. It's going to flow from your Revit model, from the actual drawing, the schedules, and it's going to go into facilities' hands. So a big portion of what I've been working with Mr. Verlet is working on the syntax, the data exchange. A lot of people throw out a lot of concepts, IoT, information. So I've been working on standardizing the information. That's been a big part of what we've been working on. So like I said, essentially, this is how I view our campus, Pepperdine. This is not our campus, but this is how I view our world. I'm trying to make all the connections, and underground, above ground, make all the connections. And I basically essentially have termed it a full traceability concept for FM, or for any building management. And the hope is to utilize this information that we collect from the buildings to support procurement, to support facility condition assessments, life cycle planning, and asset management. So essentially the full spectrum of all of the information above ground, below ground, everywhere. So this is just a glimpse of, once again, how I view the campus. This is actually our campus here. And we had a great partnership with some partners doing the utilities. So we're trying to make these connections, trying to get all the information as accurate as possible. And just a little bit of a glimpse of this utility map. Positioning all of this information, the names, manhole covers, responsibilities, roles, all of this information intersects. Who has their utilities? What do they call it? Who owns it? All of this is just language, syntax, information. Standardization has been assisting in us in defining, figuring out where all these assets are, and more importantly, is just the positioning of these assets. So we're using as many tools as we can. Here's a screenshot of this goes into what we've been all viewing today is the IoT of information, IoT of everything, the concepts of having unique serial numbers, barcode numbers, connected to smoke alarm systems. There was a recent recall from Honeywell, I think 20,000 smoke detectors. That's a lot of information. The Revit drawing has it. Oh, sorry.
Can I jump in?
Absolutely.
Thank you, Gabe. So my name is Cyril Verlet. I'm the president of CDV Systems. We've been providing Revit services to the AEC market since 1992, CAD initially, and then Revit starting in 2002. So our Revit, our BIM services got sort of timeline. We've been providing Revit services to firms around the world since 2002. We've got involved with this external database called CODEBOOK, which is a SQL Server database, in 2005. 2012, we have a partnership with a company, 26 Degree Software, with a product called VUAQC. And just last year, we started getting involved with 3D photo scans. So we provide services in terms of Revit and BIM, full BIM execution plans, 3D photo scanning, executive training for the executives, both more so in the architectural firms, firm-wide implementations. You'll see a list of clients here in a second, setting up standards for either projects or full implementations. We always call it train the project. Our focus has always been project-centric to make the project successful. And so whatever that means in terms of providing BIM services for the success of that project, that's our key. And then BIM mentoring, BIM modeling, BIM auditing, what have you. These are some of our clients. We set up the standards for AECOM, HOK, SOM, MBBJ, Canon Design, big architectural firms. Now we're moving this into on the owner's side. Okay, I'm going to pass it back to Gabe, and you'll see where I'm coming from.
Okay. So when I look at assets, I really, once again, I don't see match lines. I don't see any divisions. I just see all the assets. So what I've been doing is utilizing drones, utilizing the AutoCAD drawings, utilizing all of the information that we have, and truly taking it down to when does asset management start? And it starts at the photogrammetry level. So what are the parameters that I need to capture from that photogrammetry? Who took the photo? This is how the CAD is developed, or the Revit plan is developed. This is a recent project that we did. This was the first step. And if you, in this very area, we now have a beautiful building that supports our students. So it's very important to kind of get to this philosophical point of when does the project start for asset management, which in return is supplying your facilities technicians with the information you need. So it's in your best interest to make sure this information is accurate. And so here's some thoughts I've been working with Cyril, is capturing additional parameters. So right at the beginning, we're going to capture control points. We're going to get all the surveyor's notes. This is relevant information. I can now then click on it, pull that information very quick. So there's no time wasted. I've been able to trim the time down really quick on how I provide information. Standards. Standards it's huge. I don't want to reinvent the wheel. Standard language, standard syntax. What do we call this thing? Is it a light fixture or is it light fixtures? Just very simple concepts. It just costs money. All it means is I got to retype it, or somebody else has to retype it, or I have to have a student retype it. I don't want to do that. I allow these uniformat. I allow master format, and then obviously asset manager, so I adhere to the ISO 5500. So these are things that I rely on heavily. And the more all of us rely on it, the more we can all be in sync and speak the same language. So here's just a demonstration of uniformat, parameters, master format. I classify all of my components in this format, and it's been extremely helpful. Most of your projects, they're doing the same thing. That's what I end up finding out. They're managing it on an Excel or something. Once again, they're using different methods of communicating the information. My goal is to get this information to flow and flow continuously and never stop, and get updated and have that whole full process of how that looks. So once again, that's just a little screenshot of important information, serial number right there, critical parameter. It's a parameter that you can pull. Why lose it? Why bury it? There's that recall. It's a real deal. It just came out. With the tools we're using, we can extract that information with a click. So amazing stuff. I'm using a drone. I found out we have a drone pilot. He's working for me now. He was just taking pretty pictures. We have a beautiful campus. It's in Malibu. I'm more concerned about the roads and more concerned about, is that valve there? And what I'm finding out is that valve is not there. So what I'm doing is taking drone imagery, stitching it into the civil drawing, and then I'm layering it, making it transparent. I'm validating the assets. And everything has a position, everything. Even the grass, the hardscape. I'm looking at exterior and interior, above ground, below ground, and trying to marry it all together in GIS. So there's that road, and that's how it looks stitched. You can see all the red marks. Those are all from me. I'm working on that right now. We barcode every light fixture. This is that Seaside project. There's a track right there. LEDs, 5-year warranty. We haven't paid for one light. All of our LEDs have been paid for by the manufacturers if they fail. How do you track that? Where is it? Using Apple AR, I've been validating all of the assets with using Apple AR. We've been good. 1 centimeter off, 2 centimeters off. That's huge. And if you can do that, or if your technicians could do that using an iPhone, that's great. So there's just validation using GIS. I use CAD. I'm using different tools. A lot of these are free. I don't even have GIS yet, so I'm trying to get everything moving, but GIS is available. Los Angeles County has a GIS program. I'm using it. And the goal is to get Pepperdine to get the GIS program and continue on. Why is location and position accuracy important? Somebody's going to dig here. Somebody has already dug here. I think DGT is here. I've utilized their services. This is their map. I'm trying to enhance what we're doing, taking a lot of this information with the help of CDV to bring this to a realization and share this information. So here's just another image of now this site is now excavated. We're getting the drone up there, capturing this image. We do physical verifications. It's dead on with the AR. So it's been fun. Our goal is hopefully this, HoloLens. But in order to achieve this, right, we're talking about centimeters, we really need to be accurate. We need to validate this information. I don't want to make any assumptions. So in my past world, we made no assumptions. I'm making no assumptions here. So that's that part. There's our beautiful utility map. Important messages, syntax, language for information, format, the program. How do you format the program, the build? That provides the path. A BIM execution plan is helpful for that. Data exchange, data interoperability. You gain a lot when you can exchange. You don't have to type, retype. Big concepts for me are preparation, validation, execution, and demonstration. Those are concepts that I've been trying to teach my team. And I want to pass this on because I do not want to take too long. Thank you, sir.
So the reason Gabe described all of this is because in this workflow, this was his focus on the outside of the buildings, and we wanted to somehow translate that into the inside of the building. So here, now we're going to take those same concepts and try to figure out how to get this information out of a Revit model into a GIS and FM format that can be used in the same way that Gabe is describing it here. So from our perspective, the first step to have a sustainable design environment, a campus, if you will, the first step that requires this is locating all the buildings, the levels, the rooms, and the assets. You have to locate the objects first in order to know how to maintain them. This workflow provides that. So here, the objective is we want to take the Revit models, combine all of the architectural FM data into, this is a multi-model, multi-trade project, into one single source, to export to FM and GIS, okay? Now the problem is that Revit doesn't populate to GIS directly. It doesn't do that. Secondly, there are some FM tools where if you can take, let's say WebTMA, this is what Pepperdine is using. You can link WebTMA as an FM software to a Revit model. Normally those Revit models, in a project, you've got 8 Revit models. You've got the architectural, structural, mechanical, plumbing, electrical, fire protection, storm drainage, equipment, furniture, medical equipment, perhaps if you're doing a hospital. And the only model that can be pushed into WebTMA is the one that has the room objects in it, the architectural. all the others have to be hand-entered. You have to hand-enter the locations of those rooms where those things exist. So if the VAV box is sitting in the mechanical model, you have to hand-enter that room location. If that room starts to change, how do you update that? So in this workflow, all of these models are consolidated into one single SQL Server database called CODEBOOK. It's a software. This is part of our toolkit. And from that source, it can then be pushed out and populate GIS and FM accurately and perfectly from that one source. So what I'm going to do is I'm going to just go through the steps of how that happens. This is the workflow. And hopefully at the end of the presentation, there'll be enough time for me to show you this 3D photo scans that are linked to the same database, and I'm going to hopefully there'll be time to cover that. So first, we're going to look at starting from scratch. We have an AutoCAD site model. It's registered with GIS. Then, how do we create a topo surface in Revit to use that site model? How do we link a Revit model in? How do we establish the shared coordinates of that Revit model in the site? This is pretty common stuff. But then, once the shared coordinates are established, how do we update the database, in the CODEBOOK database, to understand the new positioning? How do we update all the assets from a variety of models, and then push it to FM and GIS? And again, if there's time, we can do the Matterport thing, or the 3D photo scans. So I'm going to start literally from scratch. I'm looking at AutoCAD here. We've got a line, and the line has two coordinates. One coordinate is 0, 0, 0. The other coordinate is some random point up in the upper right corner. This length of line is roughly 1,100 miles. It's got an X and Y coordinate in terms of miles. If I zoom in more closely to that line, it's an actually corner of part of Pepperdine itself. It's the corner of the building. And so we're going to look at three positions of the building. The X and Y coordinate of that corner of the building, this happens to be Payson Library, and its elevation. So if I look at the elevation of the finished floor, it's 390 feet plus some change in terms of elevation. So those are the three positions that are critical to get this whole thing started. Everything has to be recognized by the position of what's happening in the site model. Then we take this AutoCAD file, and here's an image of part of the AutoCAD file here. If we start tipping it sideways, and this is just a portion of it, the contours, of course, we changed to be pink so you can see them a little more easily. As I tip it sideways, you can see that the contours are correct. You can see the points that were listed in this particular AutoCAD file are not quite correct. That's okay, because we've got the contours. We also have the graphics, the footprints of the buildings themselves. And if we tip it completely sideways, the contours are all perfectly horizontal. We take that AutoCAD file, we bring it into Revit, and then we sort of remove some of the layers, and here we have the footprints of the buildings sitting at 0 elevation. Here we can bring them up to the proper elevation. We put a topo surface on it. We establish this kind of thin vapor barrier, if you will, representing the finished floor elevation. Then so now we've got this Revit model of the site. Now we link in one of the buildings. It happens to be Payson Library. We link it in, and it comes in at 0, 0. We have to position it to the right spot, raise it to the proper elevation, rotate it to the proper angle, and make sure that it's positioned properly within that model. And if I zoom in to the corner of the building itself, you can see right there, that corner of the building itself matches, and there's the elevation of the finished floor. Those match the original positioning from the AutoCAD file. So the position of the Revit model understands itself now within the shared coordinates of the site. Again, GIS positioning. Now we go to the AutoCAD, the Revit model. We activate its position, its shared coordinates. We publish those coordinates back to the model itself, so that if we go into that model and look more closely at the lower left corner right there, that model with the previous position now understands its corner position being that spot, and that same corner is the same corner coming from GIS. Likewise, the level, the finished floor level, is the same. There's 390, and there's, again, 390 and some change regarding the finished floor. So the building, the architectural model, Revit model, now understands its position within GIS. So now, and of course, any linked models, we update the shared coordinates of those linked models too. Again, this is standard Revit stuff where the models are all updated. So now we're in the database. And now we have to update the database. We first update the rooms, and the rooms is we just synchronize the rooms. The database is updated. And then we want to check one of the rooms, and if we go to that room, the synchronization has been updated, and this room is happy. But notice I've got a linked model here. So this image right here shows the room object of the architectural model. This image shows a linked model, which is some furniture. Now in Revit, I can't take the location of, in this case, chairs and furniture. It could be, light fixtures. It could be diffusers. It could be whatever that's in a different model. I can't expose that to GIS because I can only expose the room location of the model that has the room objects in it. But here in the database, each room lists the assets of every model that's linked. So here's the list of assets from the architectural model that's here. Here's the same room with a different list of the assets from the furniture model. So what's happening is that this database is consolidating all these models together into one single source of truth. Okay? And not only is it gathering the position, it's gathering all the data attached with it, whether it's coming from Revit or whether the data is inside the database itself. And that's instance and type parameters, if you're familiar with Revit. And of course, this is a list of all the assets that are there. So now we've synchronized the rooms. We now want to synchronize the equipment, because the equipment has to be updated as well. And there we choose which model that we're in. Again, it could be one of 8 models that are synchronized. And once that's done, we push it to GIS. So here, as an output, it's simply a report out of the database. We can push from the report to Esri as an XML file, a GBXML file, listing all the rooms and all the assets. Okay? When that gets pushed, it creates a file format that slides directly into GIS, Esri, Blue Mapper, or QGIS. So here's an example. This is Blue Marble Global Mapper. It's literally a drag and drop. From these shape files, it's a drag and drop into the GIS model. Okay? It identifies every room and every asset from this consolidated model into one single database. Okay? Here's an image of QGIS. Same thing. All the rooms relative to GIS, perfectly positioned, level to level, and all the assets in the GIS model. It's unheard of. I mean, you can't do this. This is what it looks like from Esri, ArcScene. And here's an image of the actual assets in ArcScene. So there you can see the lower level with all the assets. There's the upper level here, and there's a third level. So now that you have this, you can use this is indoor GIS just from a database. And now that you're populating the GIS model with all the rooms and all the assets from this consolidated Revit model. Okay? And so just to make sure it's clear, if I zoom into, let's say, a light fixture in a reflected ceiling plan, and there's the coordinate position of that light fixture, I can find it in the database. It can locate both fixtures. There they are. And then if I look at ArcScene or ArcMap in GIS and zoom into that location, there's that same fixture. There's the coordinate position. It's perfectly accurate. It's the same position, both X, Y, and Z coordinate. Okay? Likewise, let's say a chair from a linked model. Here's the chair. There's the position of that chair. And again, there's that same chair, and there's the position of it, and it matches perfectly with what's coming out of Revit. It's a perfect match. Okay. Now, locating all the assets is the first step. And Gabe had mentioned, now we want to take all the data and have a common syntax of all the parameters that Pepperdine's using to manage their facility. So what we did is Gabe provided an Excel file that had 27 tabs, and each tab represented fan coil units, boilers, pumps, floor finishes, door information, air handling units, equipment, assets, all these different parameters that somehow wanted to be utilized and addressed to all the assets in his workflow. What we did is we combined all the parameters into a common list. So here you can see, for example, the parameter notes occurred in all 30 tabs Okay, the parameter of manufacturer's part number occurred in 28 tabs. The term, fixture type or motor return fan number 1 only occurred once in the VAV, tab. But these are parameters that we wanted, and the parameters that we wanted go into different buckets. Some were related to room objects or rooms. Others were related to equipment as a library parameter. Let's say it's the equipment manufacturing number, it's the dimensions, it's the type, it's the cost. Other parameters had to do with instance values. So in this room, those light fixtures were installed on a certain date. They have a certain warranty amount. That data was brought in as well. Okay, that's all part of this structure. So the database provides a mechanism to place that data in all these different buckets to then expose to both FM and GIS. So here's an image of that where this particular fixture has all these parameters from the library. So out of the database, because WebTMA accepts Excel files as an importing mechanism, we then take this information and take it out of the database and put it right and populate WebTMA with everything, all the rooms and all the assets. So in this case, all the rooms are listed by building, by department, by level, by room number, and all those various parameters that go along with it. And then in terms of the equipment, all the equipment is pushed in from one Excel file with all the parameters, the syntax that Gabe was describing, into the FM software, WebTMA in this case, and again, all the library data. And also, if a contractor was to submit an Excel file that was not in Revit, it too can be brought into this database and exposed to FM and GIS also. There's a mechanism, there's a way to do it in GIS as well, even though it doesn't physically exist. And that too, that information can be brought into the database, into WebTMA. And then last is all the instance data. So now you have certain requirements for equipment fixtures that a fan has to have a filter replaced on a certain date. What's the installation date? What's the warranty date? That too is brought into WebTMA. Okay. So the intention here is we're just trying to find a mechanism to consolidate the data and expose it to the various programs, whether it's FM or GIS. And this here, the database also provides a tool where you can compare the required equipment from the program to what's actually in Revit. And it just provides a tool to flag discrepancies. We call it the red, blue, black report, an RBB report, to flag discrepancies, in whatever's happening here. Okay. All right. So to recap, we talked about Gabe's intent for how he was using data information on the outsides of the building, and with the intention that that same workflow wanted to be brought inside the building. The problem was, how do we populate our GIS model to do that, or how do we populate WebTMA to do that? And that's what this workflow is about. So, okay. So before I do the Q&A, I'm going to actually give you a live demonstration because I think we have time. Actually, we've got. Are there any questions? I want to show you something with regards to 3D photo scans because I think this is part of the workflow. We took it out of the presentation, but I'm gonna since we have time, I can throw it in. But yes, questions.
Are you making a separate shapefile or a separate feature class for every building when you do this?
Yes, each building gets its own database. Okay. Correct. Because we want to make sure that when the GIS model gets populated, it's by building, and with all the parameters that go along with it. Too. There's obviously mapping involved with the GIS, but whatever parameters, again, they've already established the list of parameters that they need to manage their facility, and now it's just making that connection, but it's literally drag and drop. Another question I saw? Yes?
So all of the data that is about the assets that are those are living, staying in Revit, or are they staying in GIS, or are they just filtered straight through into FM?
They stay in Revit, okay. They stay in GIS, and they get populated into FM. At some point when the model updates, the model can be updated, and that can update the GIS model as well. You can grab a portion of the models, you can grab a portion of the building and send that into GIS. You don't have to grab the entire building. You can actually do portions of it. The answer is yes. I'm curious, is your schema, do you have existing Revit models?
No, well, we don't use them.
Okay. Well, those could be used. It takes about 2 days to take a Revit model to update the rooms into GIS. It takes about a day to do the equipment, to update the equipment. Okay. It takes a little bit more time, a couple of weeks, to establish all the parameters. At the very most, to establish the parameters, you've got a list of parameters. We've got them in Revit. You've got a list of parameters in GIS. We want to map the two. We want to make sure that they're created properly. It's a short time. Yeah. So interestingly, we're not requiring the architects or engineers or contractors to use the workflow, but in the BIM execution plan, it will define the required parameters to fill in. And we will provide the Revit models that have the schedules of the parameters to be filled in, and those are the parameters that would slide right into this workflow. It would auto-populate the codebook database, which then goes right to GIS. And it's a good mechanism to also check to make sure that they've filled everything in. If we give them a Revit schedule, these parameters should be filled in. Yes.
Does it work the other way? If I were to update a parameter in GIS, would it be able to?
It does.
override it?
We did it for USC. We proved that as a proof of concept. We did it for USC.
Okay.
So yes, we can do that.
And
Yes.
web TMA as well?
We haven't tried it with OpTMA. Haven't tried it yet. Okay. I mean, it's an open architecture. Yes.
Question for you.
Sure, Devon.
You guys are you using the interface tool? So you usually because you know how
Yeah,
we're doing it
right.
with
Right,
with
no.
TMA and Revit,
Yep.
but you're doing it different.
We're doing it from Excel right into WebTMA.
Yeah, doing it direct, essentially, yeah, that's it. And
Okay. No, I was just wondering, because she asked that one question, but yeah, I didn't know if you guys were using that tool, that interface tool that TMA created.
Right.
Yeah.
To link to.
What's interesting is this does not require any hand entering of room locations of rooms or locations of it knows where the objects are. And we did this works with Maximal also. We've done it with Maximal too.
And
So-
just to let you know, so this effort was done on Payson Library, a library that we had. It was a remodel. So essentially, it was just gutted out. So what I did is I observed a lot of the interactions with all the information, and then that's what we. So essentially, this is a remodel, and this is the result of validating some concepts that we thought we could achieve, and we were able to test it, and it worked. I think
Yeah.
it's fairly robust. And I love CodeBook. More importantly, is what I love CodeBook and CDV's efforts is that it provides a validation tool. So I think I've expressed that to you folks, is that validation, it's very important. It's a very important process in this flow. And I believe we ended up finding some errors. We would have never known that. And to be able to
Quite a few.
to run a report to say, this is there. And I think we all know that it's very important to know that equipment is there, wherever, and the position, it has to be right. So it's a pretty powerful tool.
What I'm going to show you is another aspect of this. Again, this is something that we're doing with Pepperdine also, is we did some 3D photo scans of Payson, the library. And we wanted the ability of having Pepperdine open the database and be able to see and visualize the room directly from the database. Okay? So I'm connected to the internet here. And let's say I want to see a 3D view of the entry hall. So I go to the database here. I run a command to say, just find this room in the database. Well, now it's going to fight with me. Okay, that's fine.
Wow.
Well, I know where it is. So it's room 200. Of course, this is whenever we do a demonstration, this always happens. So here, there's the room. It's that room right there, entry hall. And I run this. There's some images of the room, and I can click it, and what this does is it opens up a 3D photo scan of the model. This is coming through the internet, and it puts me right in the position of that room. So rather than try to fish through the room, I can actually go to the room. Come on, this worked like beautifully half an hour ago. So there it is. So there's the entrance. You can see I'm right at the entrance of the building here, and I'm just moving my mouse. And I can step into the building and move around in the building and look around. And if I'm a maintenance person, I can check to see what the floor material is. I can look at the light fixtures and see what's going on there. Likewise, if I go to a different room here, I want to go to the room above, room 301. I find 301. And again, it's directly above the entrance. And again, I can click it, and it takes me to the same model, but that location. Okay. So there's that same model, and there I am. And of course, I can actually walk into the building. I can walk down the stairs here. You know, it's actually pretty slick. It's a fantastic way of visualizing, and with Google goggles, you can walk through it. You can actually walk through the building, and we're actually scanning one of the buildings for the students to be able to see the building, see where the entrance is, find where their room is, and actually walk into one of their units. That's the we're going to be scanning that probably next month. So.
Yeah, so I'm essentially looking at, I want all of the points. So essentially my goal would be that the technicians would be able to click on each individual light because it's just not good enough to say, hey, there's a light out at the library. Even saying there's a light out at the hall, well, there's, I think 12 lights or 13 lights, something like that, and they're only in that hallway. And each light has a 5-year warranty. There's a distributor that's connected. There's a lot of pieces of information. You can't just go direct to the manufacturer. You got to go through the distributor. So all of this information can be embedded, and that's a value. The technician bringing an 8-foot ladder because he or she has the information available.
Right.
What does that cost? Well, at Pepperdine, we're working on parking. Parking's a big issue. I think a lot of people have mentioned parking, student parking, access. Technicians need to get there very quick. We don't want to waste time. We want to try to be proficient in our work habits, and we're looking at strategies. That's what we're doing. We're trying to get in position, get everything accurate, and then start moving forward. But
this is the same room. This is a different room. Come on. Because I want to show you that the scanning can be done in phasing also during construction. So here's an image of the room, of a room, down below, next to the entrance. I could walk into the room, or what I can do is also look with that same room, look at a different model. Now, this is not the same building. This is obviously a different building, but scanning construction. So there you can actually use the database as a mechanism to manage all these various scans at all through phases of construction, whether it's slabs, you know, the framing, mechanical systems are going in. So there I'm looking around here, and I can walk through this building. It's obviously a different building, but you can see that this kind of mechanism. Oh, there we go. Okay. Or you can attach data, and this data can be attached to the database also. Let me find you a room here. If I go to this room, again, I'm doing this live. And here, this is just this mechanical room. It's a different scan again. So here I can actually walk into the room and see this, and if I walk over here and actually get a closer look at this information, I can attach these tags to the data, attach the tags to the model. And if I walk back over here, I can actually attach documents to the model. So if I click on this object and click Operations Manual, I can click it and up pops the Operations Manual. Okay? I can attach the manual inside the database also, whether it's to a piece of equipment, whether it's to a room, whether it's to an instance of that piece of equipment in the room. Again, I'm really beating up on the internet here. This should pop up. But the idea is, what Gabe was showing you at the beginning, the intention is to do the same thing within the building itself. And this is how we can, of course, this is how we can get to it.
yeah, question?
So you said that, I mean, this is really cool. You can see a picture of what the room really looks like, but I'm envisioning
Matterport?
No. The Matterport scan, this is more of a visualization tool. And what's interesting is that you can scan the model. Let's say you scan the entire building. Again, these pop right up with these O&M docs, so I'm sorry that they're not coming up. It's just a bad connection. But you can scan the entire building, public, private spaces, and then you can make a copy of that database or copy of that scan and have one for the public, which allows access into the building and to all the public spaces. You don't want them going behind, back of house stuff. And you can then have a second model that's more for the facility side that's locked down, that only the facility people at Pepperdine would access to. But there's no mechanism to turn the layers on and off. It does create a point cloud. Okay. But what I found, the point clouds exist. Unfortunately, the point clouds with these kinds of scans, they're not as accurate. I mean, if we did a scan of this room and then walked to the other side of the building on the second floor, there's discrepancy. It's not a perfect match. There's tricks to do the point cloud, and you can stitch the clouds together. But I think that as a tool as a visualizing tool, I think it's brilliant. That you can actually walk in the building, and for the students who want to see the building beforehand, parents who want to get a virtual tour of the building, because you can actually be on campus. We've got this. Let me see if I can bring this one up. This is a pretty cool slide. If I can get this one here. This is inside and outside of a building. Right here. This guy. Again, are there any questions? I know we're just a few minutes before we end. Yes, Mike.
If you were to go back and rescan a room in the future, say some new machinery's put in,
Right.
and you do another scan.
Yep.
Can you put in the geographic tags, metadata that's still good?
No. You could add the scan in. You can mesh the scan so that when as you walk into the room and you walk into the space, it would activate a different model that would show you what that space looks like. And then as you leave, it'll bounce you back to the other model. But
Thinking about the labor, how the manual labor to tag to the part number.
yeah, I think that the tagging, in my mind, there's definitely labor involved. It seems to me the data wants to be in the database. That's where the tagging would be, and that's far easier. And attaching equipment is so much easier. Right now, Pepperdine, there's roughly 500 pieces of equipment, unique pieces of equipment in a library, and the plan is to take that same from the database. That same library will get much bigger as other buildings are added in, but the beauty is that this one VAV box that exists in the library, this is where we attach all the O&M data and all the manufacturing information to that piece of equipment, and anywhere on the campus, you click that piece of equipment, it'll bring up that information of that one piece of equipment. It's not building specific. It's the entire campus, available for the entire campus.
This may be helpful for you to maybe grasp. I don't have a team. I don't have anybody.
I've lost my.
I have Cyril, but I don't have. I am the asset manager. I physically go out and tag assets. So I don't have a team. I don't have a design team. I don't have an engineer. I don't have anybody, supporting this effort, and that's what took me to this gentleman and CDV, essentially, because I don't have a team. I have a team, but I don't have time for a whole team to get together and let's put all this together. We need to move quick technology is moving fast. So, and a lot of people are offering a lot of information. So I need to be concise in my moves. So that's been my focus, is how concise can I be? How can I get as much value out of my efforts? Because I think we're up to about 10,000 assets that are actually barcoded in our WebTMA system. Furniture, HVAC, underground utility. We're getting a little bit big, but I don't have a lot of resources. So we're trying to build something that will hopefully provide us the structure, the human resources, et cetera, and put a lot of this together to make it more robust and help our processes.
I think the intention is to populate the GIS model to populate WebTMA so that there's no hand entering. That's the key.
Right.
You know, in order, again, sustainable design or for a sustainable facility, you got to be able to have everything available to you, all the data, and
Yeah, it has to be available, it has to be accurate, and we have to move with minimal resources. So my focus is stick to the drawing, make it accurate, keep up with the drawing, focus. If we can focus your energy on the Revit or the GIS map from all of your team, you're going to get better results. And then BIM execution plan, all of
Yes.
these other activities.
right.
So, yeah, thank you for your time.
Yes.
Thanks.
How does this work whenever a renovation happens to the space in the Revit model? So
Right.
if someone would update the Revit model, and then would you have to push the entire building over again?
No, just that portion.
Okay.
Just that portion. You can isolate in that screen where I showed you exporting the entire building. You isolate the rooms you want and push those.
Okay.
Yeah.
Thank you.
Okay. Thank you very much.
Thank you.
Thank you. Thank you.